The last item in section 2.1 is a discussion on parallel and perpendicular lines. Should remember from geometry class, two lines are parallel if they never cross each other. That was our geometric definition of parallel lines. Well, one thing I know about a line is, hey, it's got a direction. Okay? And if two lines never cross each other, they have the same direction, and we call the direction, when we're talking in algebra, is the slope of the line. So that's going to come up with our algebraic definition of the slope of a line. And that is two lines are parallel. And actually, we need to caveat that and write two non-vertical lines are, and that's the geometric symbol for parallel, but I usually put a line under it so you don't know you know it's not an 11. So two non-vertical lines are parallel if and only if their slopes are equal. Okay? And again, I have to use the word non-vertical in the definition because we do not have a definition for the slope of a vertical line. So to add to this, well, what do we know about all vertical lines? Well, all vertical lines are parallel to each other. So that's what we're going to write. All vertical lines are parallel to each other. The other thing I need to talk about is perpendicular lines. And we should remember from geometry, perpendicular lines are two lines that form a right angle. And if I get rid of the case of vertical and horizontal lines, you should notice that one of the lines is pointing uphill and the other line is pointing downhill. So we know that, hey, if a line's pointing downhill, it has a negative slope, and if a line's pointing uphill, it has a positive slope. So that's one thing you should note about two perpendicular lines. We will actually come up with the actual definition of perpendicular lines is two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So what I'm going to do is I'm going to write what this is mathematically is, hey, the slope of the first line times the slope of the second line has to equal -1. What you probably remember from middle school or geometry class is this written in a different form. I'm going to divide both sides by the second slope, and I get the first slope is equal to -1 over the second slope. And 1 over a number is the reciprocal of that number, and then I multiply it by a negative number. So the way you probably remember it is two non-vertical lines are perpendicular if their slopes are opposite reciprocals. But the actual mathematical definition is the product of their slopes equaling -1. So if you want to determine whether two lines are parallel, you just compare their slopes. The easiest way to compare the slopes of two lines is to rearrange it into slope-intercept form. Same thing. To check to see whether two non-vertical lines are perpendicular, rearrange the equations for those two lines, multiply the two slopes together, and if you get -1, they are perpendicular. So an example of the types of questions you may have to do is I want to write the equation, actually two equations. I want to write the equation for a line that goes through the point 4, 1, that is both perpendicular, the first one perpendicular to that line, and the second one parallel to that line. So my first step in order to write an equation for a line is I must have two pieces of information. I must have a slope, and I need a point. Well, they gave me the point 4, 1. So in order to write my parallel slope, I actually need to rearrange this equation and figure out what its slope is. So I'm going to solve that equation for y, put it into slope-intercept form, and read the slope directly off of the equation. So I get 5x minus 3y equals 8. Subtract the 5x from both sides. So that's negative 3y equals 5x, negative 5x plus 8, and divide both sides by negative 3, and I get y equals a positive 5/3 x minus 8/3. What I'm concerned about right here is this is the slope of the line that I want to write the equation of a line parallel to. So my parallel slope has got to be the same, which is 5/3. So to write the equation of the line, remember y minus y1 equals m times x minus x1. So substituting in, I get y, the opposite of the y coordinate, minus 1, equals the slope, 5/3, times x, and the opposite of the x coordinate. And the directions did not state to solve it into slope-intercept form, so this right here would be the answer for the equation of a line that is parallel to the line 5x minus 3y equals 8 going through the point 4, 1. The only difference is now I need to calculate my perpendicular slope. Well, the slope of a perpendicular line is the opposite reciprocal. So the opposite of this number would be negative, and its reciprocal would be 3/5. The equation for the line will be identical except for the slope changing. So I'm going to copy this exact same thing. Instead of where I have 5/3, I'm going to put the negative 3/5. So y minus the y coordinate equals the slope, negative 3/5, times x minus the x coordinate.